All right, let's dive right into a massive technical challenge. We're talking about picking the perfect database for a giant Internet of Things network. Now, this isn't just theory. This is the kind of real-world problem that keeps architects at major tech companies up at night. And we're going to break down exactly how to solve it.
So, put yourself in the hot seat for a second. You've just been handed a huge project. Build the data backbone for a massive IoT network. We're talking millions of devices, all about to send you a constant, overwhelming flood of data. This isn't a trickle, it's a full-blown data tsunami. The success of the entire project? Yeah, it's resting on your shoulders. So, which database are you going to bet on to survive?
And let's be clear about the scale we're dealing with, because it's just insane. We're not talking megabytes or gigabytes. We are looking at 100 terabytes of brand new data every single year, and you can bet that number is only going to go up. That is a colossal amount of information that has to be stored, managed, and ready to go in an instant.
And it's not just about the size of the data, it's the shape. Every single piece of data coming from these devices has over 100 different attributes. Think about it. Sensor readings, timestamps, GPS coordinates, device status. The list goes on and on. It's a huge, sprawling data set, and those fields might even change over time. Right off the bat, that kind of complexity knocks a bunch of traditional databases right out of the running.
So what are our non-negotiables here? What absolutely has to work? First, high availability. The system can never, ever go down, period. Second, low latency. When we ask for data, we need it back, and we need it back fast. Third, we have to be able to query individual fields to really dig into the specifics. And finally, here's a big clue, we don't need strict ACID compliance. You know, that super rigid set of guarantees from old school databases. By ditching it, we get to really open up the throttle on speed and scale.
So after sifting through all the options, you're left with three heavy hitters. You've got MongoDB, the flexible powerhouse. You have Cassandra, the always-on workhorse. And then there's HBase, the big data specialist. These aren't just any databases. These are the tools literally built for this kind of fight. But the real question is, why them? Let's get into it.
Okay, first up, MongoDB. You can think of this one as the flexible powerhouse of the group. If you're dealing with messy, unpredictable data, the kind that doesn't play nice and fit into neat little rows and columns, well, this is where MongoDB really starts to shine. So, how does it stack up against our checklist? Well, that 100 terabytes, it handles that by scaling horizontally using something called sharding. We'll get to that in a sec. Those 100-plus messy attributes? No problem. Its flexible document model eats that for breakfast. No rigid schema needed. And digging for specific data? Yep, its query engine is an absolute beast for that. Okay, so I mentioned sharding. What the heck is that? It actually sounds way more complicated than it is. Imagine you had one single giant phone book for an entire country. Trying to find one name would take forever, right? Sharding is basically just ripping that phone book into smaller, manageable volumes. You put names starting with A through C on one server, D through F on another. You get the idea. It's a simple trick that makes finding your data ridiculously fast when you're dealing with a mountain of it. All right, let's shift gears to our other two champions, Cassandra and HBase. Now these guys, they're in a league of their own. If your biggest nightmares are downtime and being totally overwhelmed by that relentless fire hose of incoming data, these are your go-to solutions. They were practically born and raised in the world of big data.
They both tackle the problem, but they have, let's say, different personalities. Cassandra is like the world's best data receptionist. It can handle a massive line of data trying to get in all at once, and it never ever drops a single piece. HBase? That's more like a hyper-efficient, specialized warehouse, perfectly designed for data that's super wide, with tons and tons of different columns for each entry.
Cassandra's secret sauce? It's all about its masterless architecture. This directly nails our biggest requirement, high availability. What it means is there's no single point of failure. There's no one boss server that can crash and burn, taking the whole system down with it. Plus, it's built for lightning-fast writes, perfect for that IoT data tsunami. And when you need more power, you just add more servers. It's that simple.
So what does masterless really mean? It's actually a pretty elegant concept. In a masterless system, every server or node is an equal. They're all peers. So if one of them suddenly goes offline, the others just go, no problem, we got this, and pick up the slack instantly. There's no panic, no downtime. It's the core idea behind building a system that is genuinely, truly always on.
And that brings us to HBase. Its superpower is different. It's a column-oriented database. For our scenario, with over 100 attributes for every data point, this design is insanely efficient. It's also a huge plus if your company is already invested in the Hadoop ecosystem because it just fits in perfectly. And crucially, it gives us exactly what we need, that real-time, super-fast access to any piece of data we want, whenever we want it.
You know, it's one thing to know why these three won, but to really get the full picture, you have to understand why the other popular databases failed. Sometimes knowing what not to choose is just as important as knowing what to choose.
So, let's run through the ones that got knocked out of the running. Redis, super fast, but it lives in memory. Trying to stuff 100 terabytes into RAM, you'd need a budget the size of a small country. Not going to happen. What about good old MySQL? Look, it's a fantastic relational database, but it just wasn't designed to scale out like this, and it hates it when the data structure changes. And finally, HDFS with Hive. Great for analyzing huge data sets? Eventually. It's a batch system. It totally bombs our requirement for fast real-time answers. It's just not the right tool for this job.
Okay, so we've covered a lot of ground. What's the bottom line here? Let's boil all this down into a simple, actionable cheat sheet. This is the kind of thing you'd want to have handy if you're ever staring down the barrel of a problem like this one.
And here we go. This is the key takeaway. If you need flexibility and rich, powerful queries, you're looking at MongoDB and its sharding. If your absolute #1 priority is never go down and you're getting slammed with data, Cassandra's masterless design is your best friend. And if you're dealing with incredibly wide, sparse data, especially if you're already in the Hadoop world, then HBase is your champion.
At the end of the day, there's no magic bullet, right? There's no single best database out there. There's only the best database for your specific problem. We've just walked through how to break down a huge challenge, look at the requirements, and match them to the right architecture. So now, I'll turn the question back to you. The next time you face your own unique data challenge, what's your move going to be?